Okay, so we are now on, this is going to be the last notes for this unit. Okay, last thing we're doing for this unit, and this we're going to work on solve rational equations. Solve rational equations. It's an S, a weird looking S. Solve rational equations. Okay, so obviously your instructions are going to say to solve. Okay, so for number 1, there's only 5 examples. Okay, if I give you 7 over x minus 2 equals 11 over 2x minus 10. And I want you to solve this rational equation. Do we have any ideas how we will solve? Cross multiply. Okay. So you got, some people I guess call it making a butterfly. I don't know, whatever. Okay. I want you to solve by cross multiplying. Solve by cross multiplying. Okay. So basically we want to cross multiply these and multiply these ones. Okay. So, and I'll write it out for you just in case. Okay, so if you were going to multiply 11 times x minus 2, then it would be equal to 7 times 2x minus 10. Go ahead and multiply that out. That gives you 11x minus 22 equals 14x minus 70. Now, we want to get letters and numbers on opposite sides. How do you know if you want them on the same sides or different sides? How do we know? If there is anything, if there is any squared terms.
Then you equal it to 0.
If there are any squared terms, you have to get the entire equation equal to 0. Okay, there's nothing squared here, so we're just going to move letters to one side, numbers to the other side. So if we move the letters, doesn't really matter which side you move it to. Okay, so if you move this, let's move it to the right, that would equal 3x. If you add 70, so I subtracted 11x for both sides, and we're going to add 70 to move it to the opposite side. You add 70, that's going to give us that 48 equals 3x. Then to get x by itself, divide both sides by 3, and we get 16 equals x. Now, for every single problem on this note, you have to check your answers, okay? Because this is getting into something called extraneous roots, okay? And if you don't check your answers, I guarantee you're going to make mistakes, okay? In this homework, it is possible to get no answers, to get no solution. It's also possible to get 1 answer or 2 answers that will work, okay? So you have to check all of them. And on your test, you will definitely have some questions that have no solution, some that have 1, some that have 2. So you have to make sure you do that. So checking the answers means I'm going to plug 16 into my original equation. So 7 over 16 minus 2 equals 11 over 2 times 16 minus 10. So 7 over 14, is that equal to 11 over 32 minus 10? 1/2 equal to 11 over 22. Is 1/2 equal to 1/2? Yes. So that one works. So that's just telling you that this answer is a true solution. Okay, so it does work. You have to check all of your answers. Okay, so if you only have 2 parts of an equation, one thing equal to one thing, that's when we can cross multiply. Okay, unfortunately, they're not all going to be quite that easy. Okay, you're going to have some that have more parts. So something like 15 over x plus 4 over 5 equals 7 over x. 15 over x plus 4 over 5 equals 7 over x. You liked the last one better. Okay, if there is more than 2 parts, more than one thing on one side of the equals, you cannot just cross multiply. Okay, these are very, very similar to what we did yesterday when we wanted to eliminate denominators. Okay, in the complex fractions, the double-decker fractions. You want to try to eliminate denominators. Okay, so you want to think about eliminate denominators by multiplying all terms. Okay, so if I'm going to multiply all these terms, if I'm going to try to eliminate an x, a 5, and an x, what do you think I can multiply through by? 5x. Write it next to every single part. Okay, every single part. Do not be lazy and just write 5x and then big parentheses. It's much easier if you write it next to every single part, because then you can actually cancel things out and it makes life easier for you. Okay, so the x's cancel here, 5's cancel in the second portion, and x's cancel in the last portion. If everything does not cancel out in the bottom, you made a mistake. Okay, then we just multiply, so 5 times 15 gives us 75, plus x times 4 is 4x, equals 5 times 7 is 35. Okay, do I want everything on one side or separate sides here? Opposite sides. So subtract your 75 from both sides. That would give you 4x equals negative 40. Divide both sides by 4. X is negative 10. Now, you cannot say that's your answer yet until you've checked it. Okay, you have to check these answers. Okay, so if I check, I'm going to plug into my original equation. So 15 over negative 10 plus 4 over 5 equals 7 over negative 10. Can I add these together right now? No, you need to get a common denominator. What is the common denominator going to be? The negative 10. So how do I get from 5 to negative 10? Multiply by negative 2. Okay, so if I had 15 minus 8 over negative 10, is that equal to 7 over negative 10? Is 15 minus 8 equal to 7? Yes. So are these equivalent equations? Yes. So that means you get to keep this answer. Question, yes?
Could we have just plugged it into 75 plus 4x equals 35?
You could. Yeah. That could work as well. Okay, you have to plug it in. Now, technically, the reason I would say you can't always do that is if you screwed up your multiplication up here, you would have a wrong equation here. Okay, so yes, but you have to make sure that your equation is right. Okay, but that's a good question because it would probably be a lot easier to plug in right there. Okay, let's try another one. Again, same thing. I want you to solve. For number 3, I would like you to solve 10 over x squared minus 4 equals 1 minus 1 over x plus 2. 10 over x squared minus 4 equals 1 minus 1 over x plus 2. So in order to figure out what's going to cancel out all the denominators, you first need to factor this denominator. Okay? If I factor this denominator, x squared minus 4 breaks to be x plus 2 times x minus 2. Right? So what would reduce away x plus 2 times x minus 2 and a 1 and an x plus 2? What's going to cancel all those out? Can I just multiply by the x plus 2? No, you have to multiply by everything. Okay, so you have to multiply all the parts by x plus 2 times x minus 2. Every single part. X plus 2, x minus 2. X plus 2, x minus 2. Okay, when you multiply those, in the first fraction, they cancel each other away. So you're left with, and I rewrote this, so I'm going to cancel it out. So you're left with just 10 equals 1 times those. Okay, I'm just going to rewrite them. X plus 2 times x minus 2. And in this last fraction, the x plus 2's cancel. And you're left with negative 1 multiplied by x minus 2. Question, Maddie?
Why do you have to do the x plus 2?
Okay, we want to eliminate all the fractions. So to get rid of the denominators, you have to multiply by everything that's in the denominators. Okay, so here, if I FOIL this out, we get 10 equals x squared. Outsides is minus 2x. Insides is plus 2x. Last gives you minus 4. Distribute the negative 1, so minus 1x plus 2. Combine all those like terms, we get 10 equals x squared. These reduce each other away. Minus 1x minus 2. Now, can I solve that equation? This is going back to, I think it's unit 5. What do I have to do before I can solve? If I have anything with an x squared in it, set it equal to 0. Okay, so move the 10. So that means we have to subtract the 10, move it over. If you subtract the 10, we get 0 equals x squared minus x minus 12. And then how do we solve a quadratic equation? There's 3 different ways. You can either factor, complete the square, or quadratic formula. Okay? Factoring is generally the easiest one. So, is this a factorable quadratic? Yes. 0 equals, this factors to be x minus 4 times x plus 3. Split these up. If you set each part equal to 0, we'll get x equals positive 4 and negative 3. Now, unfortunately, you're not done. Okay? You now have to check both of these numbers. Okay? Because earlier I told you it's possible that none of them will work. It's also possible that 1 will work or 2 will work. Okay? So you have to check them. Okay? You have to check each one. So, if I work this out, okay, if you check this, you would get 10 over, so I'm going to check the first one, I'm going to check the 4. Okay, 10 over x squared, so 4 squared minus 4 equals 1 minus 1 over 4 plus 2. So 10 over 16 minus 4 equals 1 minus 1 over 6. Gives you 10 over 12 equals 1 minus 1 over 6. This reduces, so 5 over 6 is 5 over 6 equal to 1 minus 1/6. Yes. You could change this 1 to be 6 over 6. So is that equivalent? Yes, that does work. So that means that's at least one of your answers. Now, there are problems that will have both answers that work. So you have to check every single answer, okay? That's why this test is a little bit difficult, okay? You have to check all of the answers. Okay, now let's check the other one. If we check the other one, we would get 10 over negative 3 squared is 9 minus 4 equals 1 minus 1 over negative 3 plus 2. So 10 over 5 equals 1 minus 1 over negative 1. 10 over 5 reduces to 2. Is 2 equal to 1 plus 1? Does that work? Yes. So you actually have 2 answers for this equation. You will have 2 different answers.